Good evening, everyone. My name is Eric Shankman, and I'd like to welcome you back to another Tech Talk in our series sponsored by Remake Labs. Today, we have the pleasure of welcoming Glen Jarvis to give us a brief tech talk on level up your developer onboarding with dev containers. So, without further ado, I'd like to pass it over to you, Glen.
Thank you, Eric. I'd like to start by thanking Remake Labs for sponsoring this Tech Talk. My name is Glen Jarvis, and today I'll show you how to use dev containers to onboard your new developers in minutes. Finally, you have the head count for the new software developer for your team. They just received their badge, their new computer, and login credentials. And what's the first ticket that you give them? Configuring the development environment, of course. So they clone the repository, and then how long to set up and configure the laptop? Is it hours or is it days? We expect it to be less than an hour, but in my personal experience, it has actually taken days. In the book, The Unicorn Project, it took a very senior developer, Maxine Chambers, 2 weeks to configure her laptop. But let's start with a simple example. Maybe we just have to install Brew, NPM, Postgres, and MongoDB, which could be installed fairly quickly. But what if we have to install Deno or in-house binary executables that are only compiled on certain operating systems or have special library dependencies? Well, depending upon the experience level of the engineer, this actually might take some time. So in our example today, we're going to install Deno and Slidev. Deno is like Node and NPM, but it actually can be used instead of Node.js. It's more secure. So like, for example, file, network, and environment access has to be explicitly granted. It has a modern API interface, no more common JS. And it will still work, though, backwards compatibility. It'll still work with NPM modules. And it supports TypeScript out of the box by default. Slidev is a program that generates slides from Markdown and can include custom styling, interactivity, etc. I'm actually using Slidev right now running on Deno to give you this presentation. So if I ask you right now, how long would it take you to configure this Deno environment? Do you think it'd be more than an hour? Let's do it together right now. Or rather, let me show you a recorded video of when I did it to launch this presentation. Here's what it took me to get Deno set up and launch Slidev on this computer for this presentation. Okay, here we go. So we're going to just go ahead and start launching VS Code, and we'll open the particular folder. Here we're going to launch, this is the talk right above, and click open. Let me go ahead and just close this other one and drag this over. Oh, look, folders contain a dev container configuration file. We're going to reopen this in a container. It's taking a few minutes to launch that container. Boom, I have a container running. I don't have Deno on my computer, but still I can do Deno task dev, and it's starting to open the slides, and we're off. So yeah, like I said, I don't have Deno installed on my computer. I don't have Slidev installed on my computer, but because I have two files in my repository and I have a VS Code extension, VS Code is able to configure a very portable dev container that contains both Deno and Slidev. So if you cloned my repo, ensured you had the VS Code dev containers extension installed, you would actually get both Deno and Slidev as well, even if you didn't install either one of them on your computer. So yeah, it's a pretty easy setup. Literally clone and open. So how is this done? In this demo, this is done with the magic of two files. Here's your first, a dev container.json file. It's used to integrate with an IDE such as VS Code, and it's the main subject of this talk. It's a structured JSON-C, JSON with comments file, and details configuring these files are at the containers.dev website. But if you just want to start small and just see how it goes, feel free to clone this repo and review it as the example. And here's the container configuration file, the Docker file inside of dev containers. It's to give you a brief glance of just how one can have two files checked into a code repo so that a consistent environment can be launched if the user wants it. Your new developer can hit the floor running on day one. Hopefully by now you can see the benefit of configuring a code repo with a dev container configuration. You get the portability and an easy setup regardless of the dependencies of the project. Now, I'd like to outline what we'll discuss for the remainder of this talk. First, we'll rewind and catch up any audience members who may not know what a container is. And for that, we'll start with the concept of a virtual machine. And then we'll build on that concept, introducing containers and then contrasting the two. After all of that, We will then do a deeper technical dive into dev containers before we wrap up. So imagine for a moment that I wrote a program that simulated a computer chip. This is done a lot when people are designing chips. And what if I combined that simulation of a chip with the simulation of another chip? And what if we combined all of those chips to build an entire computer and software from the ground up by simulating all the chips inside of it? This is not as far-fetched as you may think. In the video game Minecraft, there's an element called redstone. Several redstone elements can be put together that simulate a transistor. A transistor is the building block of chips. This image is a computer that was built inside of Minecraft. It really is a computer inside of a game, which is inside of a computer. Here's a screenshot of my Mac OS computer. I have a Debian Linux virtual machine running, and if there's a program that isn't available in Mac, I can still use it. If there's a program on Windows that I need, I can still run that program in a virtual machine. Here's another example. In this screenshot, I have Mac OS computer running inside of Mac OS computer. That's pretty cool. And in this particular example, they're running different versions of Mac OS. So virtual machines can have several benefits. For example, a virtual machine can be completely isolated from my main computer. If I have a virus on my virtual machine, it's separate from my main computer. I can get a lot of flexibility too. If I need something from a different operating system, I could install a small virtual machine for that operating system. I could set up a shared virtual hard disk so that both computers have access to it so they can share data. I also get portability. I can copy that virtual machine hard drive to another computer. And then when I boot it up, I'll still have all of my data, preferences, etc., in my virtual machine running on a different computer. Virtual machines are a great way to experiment without messing up your main computer. For example, I just installed the latest Mac OS, Tahoe, on that virtual machine I was showing earlier. I could ensure that all of my programs are still working. I do this to make sure that everything's fine before I actually upgrade my main computer. And finally, if there's any kind of legacy program that just can't be installed on a new OS, I can run that old program using a virtual machine on an older operating system. So, virtual machines have a few drawbacks too, though. For example, a virtual machine can be pretty heavy. You have to install an entire operating system to just use one program from that operating system. This can be pretty resource intensive. Okay, we found very clever ways to be more efficient. Under certain circumstances, the virtual machine does not have to be running a program simulating hardware. Instead, it can share the resources with the main computer. And going forward, we're going to call this main computer the host computer from now on. But even then, this emulation of hardware is pretty slow. So, for example, getting a video game made for Windows to run on a virtual machine is a pretty challenging task. Often, it just isn't practical. It's also slow to boot up a whole virtual machine to run one small program. And often, we only need that one small program to run. So, just think how much is in a full operating system. Do I need Firefox or Chrome to be installed just to run a program like Node.js? The image to the right shows a virtual machine. And just like we called the main computer the host computer earlier, we're going to call the virtual machine that's running the guest computer, host and guest. But in this image, we also show something called a container. Notice how much bigger the guest OS yellow area is compared to the yellow area of the container. These yellow areas are not to scale. Operating system sizes are generally gigabytes, while some container images can be as small as 5 to 10 megabytes. Extreme examples can be as small as 1 megabyte. But to make this more intuitive, some back-of-the-envelope calculations show that you could roughly fit tens of thousands of container images on an iPhone. So containers are much smaller than virtual machines, and a container is meant to run just one program. A container image, think of that like its hard drive, really only needs as much software to run that one program. And their resources are also controlled so they can't take too many resources from the host machine. They have the same benefit of virtual machines: isolation, done through Linux namespaces; flexibility, you can put these on other computers. In fact, you can just push code into a repo, like you push code into a repo like GitHub. You can actually push these images into a repo like Docker Hub. We also have portability. Just like your virtual machine hard drives had all of the information and settings, these container images have everything you need to run other computers, on other computers, or even in the cloud. So now that we've quickly reviewed containers in general, let's dive into what a development container or dev container is. Most people know containers in the context of production environments, but dev containers are becoming popular for development workflows. Dev containers are defined by the Development Container Specification, an open standard. So what does that spec actually give us? It lays out metadata, features, templates, and schemas that describe how a dev container is built and used. For example, the dev container JSON file, along with the metadata and labels, are all part of that spec. The idea is to create a common way to describe, share, and run dev containers so developers get consistent environments no matter which tools they use. Now let's break down those main pieces. First, metadata. That's where you declare the basics, the base image, what needs to be installed, and any configuration that's required. Next, features. Think of this as reusable building blocks like a Node.js installer, a Go toolchain, or a database client. So if you don't have, you don't have to reinvent the wheel. You already have these rebuildable blocks. And finally, templates. These are the built-in dev container definitions for popular use cases like Java, Python, or web front-end products. There's also a reference implementation schema, which makes it possible for tools across the ecosystem to support that standard. So now you know what a dev container is. You saw me start a brand new dev container with an environment that isn't even on my computer. You saw that I had 2 files. Really, I could have accomplished this with 1 file, the dev container JSON file, but I wanted to show that we could connect it to a Docker file as well, and we can customize as much as we need. If you need more than 1 container, you can actually use a Docker Compose file too. So why not put containers in many of your repos? The user doesn't have to use them. But if they're present, then we could use them. And that would make onboarding so much easier, and we would have a consistent environment. Okay, so that new developer was up and running so quickly, she already finished her first ticket. And it wasn't an environment setup ticket. It was real value that she was able to provide to the customer that quickly. This slide presentation is also the demo. Feel free to clone this repo and try it to open it in a dev container. After you have that dev container, just launch the slides and type Deno task dev, and you'll actually have everything up and running just like I do for this slide presentation. I'd like to thank Remake Labs again for sponsoring this Tech Talk. Eric, let me turn it back over to you.
Thank you so much, Glenn, for this informative talk. And thank you everyone for coming out tonight. We'll see you at the next one.